In this video, we'll be learning how to evaluate functions for a given value. So before we begin evaluating functions, we need to talk about what the notation for function notation might actually look like. So before I write it out, I want you to know that function notation is simply a fancy way to represent the y value of a function. So for example, we typically write equations in a way such as like y equals 7x plus 3, or maybe it's y equals 3x squared minus 4x plus 2. So we typically write equations in that way. However, function notation exists because if we're dealing with multiple equations at once, it can get very confusing to have multiple y values. So when we have function notation, we'll write it in a way that looks like this. So instead of saying y equals 7x plus 3, we'll say f of x equals 7x plus 3. And this is really just naming this equation to be function f. Or we could maybe do this one to be g of x. And we're naming this equation to be function g. So that way, if we're talking about these equations, we can refer back to them pretty easily. And so the g of x and the f of x are just notations that are fancy ways of saying y. And the x in here isn't like f times x, it's just saying that x is the variable that's involved in the equation on the right-hand side. So the most common way you're going to see function notation is written like this. And it might be a problem that's as simple as just evaluate this function at f of 4. And so to give you some insight into what this is actually saying is because we've taken the x part and replaced it with 4, there's not an x in here anymore, what this is really saying is we're going to evaluate the function when x equals 4. And so what we're going to do is we're going to take this x value that's equal to 4 and we're going to put it in to function f. Okay, so here we're going to take 5 times 4 minus 6. So 5 times 4 is 20 minus 6 is 14. And so what this notation is really saying is that when x equals 4, y equals 14. Because remember, that f of x part is a fancy way of saying y. So that notation is really just asking us to put that x value into the equation and then to identify what that equation will equal for that x value. So let's take a look at a few more examples. And on this page, I purposefully put two functions. I put f of x and g of x so that we actually have to decide which one we're going to use for each function. And so for this first one here, it says find f of negative 3. And because we have the f here, that's telling us we're going to use this function that is the first function. Those names are important. That's why we use function notation. So this notation is telling us we want to evaluate the function. So we want to evaluate function f when x equals negative 3. So we can really just go to the equation and put negative 3 in wherever there's an x value. Now you're going to notice that I like to use parentheses because if I plug this into my calculator, I want to make sure that it's going to catch those negatives correctly. And so you can either calculate this by hand or you can use a calculator to help you do it. If you calculate it by hand, you'll do order of operations. So negative 3 squared would be 9. 2 times 9 would be 18. I'd use keep change here. Negative 5 times negative 3 would be plus 15. Plus 3, we add those together and we get 36. Now, as I said before, you are also okay just plugging that into your calculator, pressing enter, and finding it. The big thing is that you understand you're evaluating the function when x equals negative 3. Now let's do this next example. So here this is saying find g of 4. This g here is telling you to use the g function because we have the name of the functions that match. So all we're going to do here is plug this in. So we have 5 times 2 to the power of 4. Again, this is an instance where you can use your calculator or you can calculate it by hand. 2 to the power of 4 is 2 times 2 times 2 times 2, which is 16. So this is really 5 times 16, which is 80. So again, you can just plug that straight into your calculator and find it. The big thing is that you're recognizing which function you're going to use when and what value you are putting in for x.